All right, this is lesson 6.5. Today we're talking about rational functions. So the difference between a rational function and a polynomial is if you look at like number 1 and number 2 here, you've got stuff in the denominator. You've got x's in the denominator. Remember, and we're going to start out small with number 1 and number 2. We're trying to get all the information we can from this without having to use a graphing calculator, because honestly the graphing calculator is going to fail us on a lot of the weird things that happen. So there's going to be some asymptotes that happen. So we're talking about vertical asymptotes, horizontal asymptotes, and something new to a lot of you, oblique asymptotes, where some of you have seen them if you've taken FST, some of you have not seen them at all. So one thing at a time, the easiest one to deal with is if there's any vertical asymptotes. Those are values of x that make the denominator 0. Because you can't divide by 0. Maybe that's against the rules, so anything that makes the denominator 0 would be bad. So let's look at number 1 here. All we care about for vertical asymptotes is the little expression in the denominator. Is there a value of x that will make this 0 in the denominator? Yeah, -1, right? So that's where our vertical asymptote is at. It'll be at x equals -1. It's a line, right? So it's the vertical line, x equals -1. All you're doing to find vertical asymptotes is looking at the denominator and seeing what values of x make him 0. We cool with that? If you want to put some notes off to the side, well, I guess I kind of typed it for you right here. It's values of x that make the denominator 0. Cool. Now it's brain time, and we have to see if there's any horizontal asymptotes. Sometimes there are horizontal asymptotes, sometimes there are not horizontal asymptotes. So there's 3 things to kind of look for horizontal asymptotes. There will be no horizontal asymptotes if the degree of the numerator is greater than the degree of the denominator. So let's check this out. What is the degree of my numerator here? Degree of the numerator is 1. Degree of the denominator is 1. So is the degree of the numerator greater than the degree of the denominator in this particular case? No, it's not. So then I look to see the second choice. I could have a horizontal asymptote at the line y equals 0 if the degree of the numerator is less than the degree of the denominator. Is that happening here? Is the degree of the numerator less than the degree of the denominator? No, it's not. Right, so I don't have this happening for me either. So I look to see if this is happening. It's very kind of complicated here. Let's just kind of look at what the requirements are. The degree of the numerator is actually equal to the degree of the denominator. Isn't that happening here? Degree of the numerator is 1. Degree of the denominator is 1, right? So that's happening. So your horizontal asymptote will be at this particular weirdo equation right here. It'll be at y equals, and then it says take the leading coefficient of your numerator and put it over the leading coefficient of your denominator. Hence that really easy day we had about recognizing leading coefficients, realizing degrees and all that stuff. What is the leading coefficient of my numerator? It's 1, right? Because it doesn't matter who comes first. It's the highest degree term. Would you agree that this term's got degree 1 and this term has degree 0? There's no x's with it at all. So I've got 1 over, what's the leading coefficient of my denominator? 1. I've got 1 over 1, which reduces to plain old 1. Let me explain that one more time. I was trying to check for horizontal asymptotes. I used this little chart right here. Checked out my degrees. That's what all 3 of these rules have to do with, is what's the degree of the numerator versus what's the degree of the denominator. And it turned out that this was the scenario. The degrees were equal to each other. So it said, all right, your equation is going to be y equals whatever your leading coefficient of your numerator is over the leading coefficient of your denominator. That sound cool with you, how I figured that out. Then the last thing to check for, are there any oblique asymptotes? Here's the rules for oblique asymptotes. It only happens in one case. If the degree of the numerator is exactly 1 more than the degree of the denominator. Is that happening here? Degree of the numerator is 1. Degree of the denominator is 1. Is the degree of the numerator 1 more than it? No. They are the same, right? Like you're looking for an example of something like this. Isn't the degree of the numerator 2 and the degree of the denominator is 1? Isn't degree 1 bigger than it, right? So there is none in this situation. None. there were no oblique asymptotes because the degree of the top has to be one more than the degree of the bottom for that to happen.
If you want to punch this in to see what it looks like, to see if all of our information matches, make sure you put the numerator in parentheses and the denominator in parentheses like so, and I'll zoom 6 it. And you can see here's this hyperbola that shows up, but let's double check that it matches all of the cool stuff that we had. We've got a vertical asymptote at x equals -1. Some of your graphing calculators will put a line there because they're older, and it's got a horizontal asymptote at y equals 1, also a no oblique asymptote. So if you want to graph, because that's fine to double check your work, make sure you put in stuff in parentheses.
Okay? Very, very, very lots of information. That's not a really good sentence, but that's very lots of information. Hence, why you're going to have this chart on the test. Cool? But we want to get comfortable with it before we actually deal with it. So let's try again. Vertical asymptotes. Again, that's what makes the denominator 0. Oh, crap, Batman. That's a quadratic expression. The easiest way for you to know how to make that 0, you got 3 choices. Factor it, complete the square on it, or do the quadratic formula. That's what you've been doing for like 3 years now of trying to solve a quadratic equation, like where it equals 0 is by factoring, complete the square, or by quadratic formula. I'd like to factor first if possible. Let's see if it's possible. When this is a 1, that's an easy scenario. Can you find 2 numbers that multiply together to be -10? And add together to be a +3. 2 and 5, right? And which one of those has to be negative? The 2. So what I will do is I will rewrite this entire rational expression over again. But I am totally going to change this, because doesn't it factor to be x minus 2 times x plus 5? Is everybody cool with, I just changed this to be that. Those are equivalent. That's what factoring is. This is the point of factoring. Finally, you're kind of going to start to see, okay, is there a use for this? You might not like it, but yes, there is a good use for this. Is that all right with you, what I've done? What's so great about this is now I can figure out the values of x that make the denominator 0. What value of x would make that dude 0 right there? If x was 2. That means that there's a vertical asymptote at x equals 2. And shouldn't there be one more vertical asymptote? Where is the other vertical asymptote at? Don't just say -5. You have to write the equation, x equals -5. Does that make sense to you how I figured those out? I used factoring, which I know you love, but it's better than doing the quadratic formula. It's faster, faster, faster. Cool. Horizontal asymptote. Got to check. It's all about the degree. The degree of the numerator greater than the degree of the denominator. Is that happening? What is the degree of the numerator? Is 0, right? Because there's no x's up there whatsoever, right? And the degree of the denominator is a 2. Is everybody okay with that? So, is the degree of the numerator greater than the degree of the denominator? Yes or no? This is a 0. This is a 2. Right? So, not happening. Does that make sense? Like people are like, isn't that a 4? Yes, it is the number 4, but the degree of that is 0 because it's like 4x to the 0th power is what's really going on there. With me on that? So that didn't happen. Is the degree of the numerator, is the degree of the numerator less than the degree of the denominator? That is happening, right? This is a 0. 0 is less than 2. So this tells you where your horizontal asymptote is at. It is at y equals 0. It is at y equals 0. And then you check, is there an oblique asymptote? Here's the rules for oblique asymptote. The degree of the numerator has to be exactly one more than the degree of the denominator. What do you think? Is there an oblique asymptote? There is none. I'll give you a secret. Can't have both of them at the same time. If you've got horizontal asymptotes, you can't have an oblique asymptote. If you've got oblique asymptotes, you can't have horizontal asymptotes. It doesn't work that way because When do you get none? If the degree of the numerator is greater than the degree of the denominator. That's kind of like this category, but if that was a 4 and this was a 1, there still wouldn't be any oblique asymptotes because it's not exactly 1 bigger than that. So that was like a little setup, little warm-up before we actually start making a graph of these without even really using our graphing calculator, sort of, kind of. All right, so let's see if we can fill out these 3 things right here. Vertical asymptote. Question is, does anything really need to be factored here? This has got some x squared. Doesn't really need to be factored, though, because it's just x squared, right? There's no other stuff with it. This is linear, right? It's all to the first power, so you don't need to factor anything. Do you know a value of x that would make the denominator 0? X equals 2. To me, those are the easiest parts of all of this, finding the vertical asymptotes. What makes the denominator 0? Determine about horizontal asymptotes. Do you have none? Is it at y equals 0? Or do I have to do a little bit of work here? What is the case here? Due to the fact that this degree is 2 and this degree is 1, there should be none, because doesn't that fit into this category right here? So there is none. Oblique asymptotes. Let's see if there are any first, because we haven't even figured out how to find them, but you just have to figure out if there are any. The only way that there are oblique asymptotes is if the degree of the numerator is exactly a 1 bigger than the degree of the denominator. Is that happening? It is. This is degree 2. This is degree 1. Is everybody cool with that? So now how do you find it? You do synthetic division. And it's actually much easier than you think. You're going to divide. The numerator is green divided by the denominator. So, but we're going to do synthetic division. Here's your denominator. We kind of did it last time. You know, like when you want to synthetically divide by x minus 2, you need to divide by the value of x that makes that 0. Should I synthetically divide by 2 or negative 2? 2. Like that, what makes him 0? So I'm going to do a little synthetic division here by 2 off to the side. This is how I'm finding the equation of my oblique asymptote. I need to synthetically divide by 2, and then this guy, the numerator, I'm going to just throw all his coefficients in there. Well, it's a squared, right? It's second degree, so 1x squared, 0x to the first, and 0 constants. Right? If that's got degree 2, shouldn't you put 3 boys in there, right? So that's why I had to put those other zeros. With me? Just trying to make it slow so we see what's going on. Now let's synthetically divide. 1 comes down, that'd be a 2. 2 comes down, that'd give you a 4, and you'd get remainder 4. The remainder means nothing to us, right? It even tells you right here, please ignore the remainder. Who cares what you get? The equation of your vertical asymptote will be oblique asymptote will be y equals. Now, can you go back and tell me what this was? This was a second degree polynomial. Shouldn't it knock it down to a first degree polynomial? So who is this right here? 1x, right? And this is a positive 2. So there's your equation right there. It's that 1x plus 2. That is the equation of the oblique asymptote. Let's look at the actual function and see if I need to do some factoring. Do I need to do some factoring? Yes, in the denominator. Please find 2 numbers that multiply together to be 5 and add together to be 6. Those are 1 and 5, right? So this guy will factor to be x plus 1 times x plus 5. Is everybody cool with the factoring of the denominator? What's so great about that? He tells you some things. I want you to notice, though, now we've got that new weird thing that I was talking about. Something really, 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 really weird is going to happen. Do you see? You have the same quantity upstairs and downstairs at the same time. That's going to cause what's called a hole in the graph, right? We'll get there when we get there, but that's the new thing that's going to happen. It didn't happen back here. I didn't have the same quantity upstairs and downstairs, right? I didn't have it. I do have it here. When I factored, I saw, hello, I've got myself a weird scenario. So let's talk vertical asymptotes first. This guy has nothing to do with the hole. what value of x makes this 0 right here? If x equaled -5, I'd have a vertical asymptote there. But let's just talk about what would happen if x equaled -1. Because would everyone agree that x equals -1 makes this orange guy down here 0, right? So I'd get this. Just don't write this down, but I'd get this. 0 times 4, because if I put -1 in there, wouldn't that little quantity right there turn out to be 4? What would the numerator turn out to be? 0. And 0 times 4 is how much, my friends? You get 0 over 0, which is a chaotic situation. You can't do 0 over 0. Take calculus, and you'll learn that there's a limit approaching that point, but we're going to call it a hole in the graph. There's a hole in the graph because at this quantity, if I let x equal -1, I get 0 in the numerator and I get 0 in the denominator. Crazy, crazy, crazy situation. So there is no vertical asymptote there, but we will say that there is a hole. So we write down hole at. And I need an ordered pair next. Could you tell me the x value of the hole? Like, what was the x value that gave me 0 over 0? -1 was the bad boy. Right? -1 is the x value. And most of you, after we finish this worksheet, will be pretty comfortable with that. It's like, okay, I've seen that there's going to be a hole, and I know that the x value of it is at -1, because isn't that the number that makes this 0 right here? How do you find the y value? You have to do this. Okay, so let me erase a little bit. Yep, sorry, that's not an eraser. You have to do, that's still not an eraser. You have to say, I'm going to cross those out. Don't they like cancel each other out? And here's what you'd be left with. Something downstairs. Don't you have that? Please do this along with me. But what the heck is left upstairs? If this guy is really gone, there's got to be something left up there. What's really left up there? Not 0, it's a 1, right? Because it's like you got 1 times that quantity right there. Y'all cool with that? So how do you find the y value of the whole? You substitute -1 into this expression right here. Let's put -1 in for this. The only place you can put it in is right here, right? So you'd have 1 over, what's -1 plus 5, baby? 4. That's the y value of the whole right there, 1/4. I put -1, which is the x value of that whole, in for x, into the simplified function, because I canceled the quantities that were the same on top of each other. Woo! Deep breath. Let's try something nice. Horizontal asymptotes and vertical asymptotes. Horizontal asymptotes and oblique asymptotes. Please see if there are any. Use the chart. Let's get back comfortable. We've done the vertical asymptote, and there was a hole. Now check those out for me. It is usually easier to look back to the original guy before you factored him, because you can see the degrees better. Doesn't this have degree 1 and this have degree 2? Right? So the degree is smaller. So of the numerator, isn't that this scenario right here, where the degree of the numerator is less than the degree of the denominator? So that's at y equals 0, baby. And will we have an oblique asymptote then? Since I had a horizontal asymptote, that answer is none. I like that little shortcut. If you put an answer for horizontal, then the other one is automatically a none. Cool? Unless you put none here, then you have to check. There's a vertical asymptote at x equals -5. I've graphed this. I got to graph the hole. I'm going to put a hole there. I put an ordered pair, -1, 1/4. Now, I got a horizontal asymptote. At y equals 0, I will graph him. Horizontal asymptote at y equals 0. And oblique asymptotes, there are none. So going back to the calculator one more time to see what this bad boy should look like. I've got a branch over here that is getting closer and closer and closer to the asymptotes. And it should go through these 2 points, but don't fill in your hole. So I'm going to do this. It's getting closer and closer this way. And then this. There is a big old hole in the graph. Let's see if I need to do any factoring before I get started, though. Before I turn you loose, let's talk about the numerator. First, can the numerator factor? Well, it's possible. You see some x squareds in there. Does it have x to the first in there also? No. Remember the old GCF concept, though. It's like, is there a GCF that could be factored out of this at all? The answer is no. So your numerator is going to stay 3x squared minus 2. Good deal? Denominator, very possibly can factor. There's x squared and x to the first. Please try to factor the denominator. Two numbers that multiply together to be negative 12 and add together to be 1. That would be a negative 3 and 4, right? So x minus 3 times x plus 4. Y'all cool with me factoring that? Before I turn you loose, my question to you is, will this guy have holes in him? Do you see the same quantity upstairs and downstairs? Here's an x minus 3. Is there an x minus 3 up there? Nope. Here's an x plus 4. There is not an x plus 4 up there. No holes in the graph. Cool? Only time you get holes is when you've got the same thing up and down. Rock on. Please do the 3 asymptotes with your pal. Okay. Everybody cool with the vertical asymptotes, right? And I bet you realize what kind of asymptote we have next. Is it going to be horizontal or oblique? What kind of asymptote should I have? I should have a horizontal asymptote because would you agree that the degrees are equal to each other, right? And then you're wondering, okay, how did we do that again? How did we do that? Leading coefficients, right? Who is the leading? So it's going to be at y equals, sorry. It's going to be at y equals leading coefficients over each other as a fraction. Who's the leading coefficient of your numerator? Again, look back to the original guy before you factored it. It's easier. It's going to be what? 3 over leading coefficient of the denominator, which is 1, which you just plain old change to y equals 3, right? 3 over 1, which is 3. So because they were equal degrees, it's the leading coefficients. This 3 and that 1 right there. All good with that. Is there any oblique asymptotes then? No. If this has horizontals, then there is a none. Do I have any factoring that needs to be done before I get started? I could factor the numerator. Hopefully, maybe. Let's try to factor the numerator. Two and 5, right? Then the first question you ask yourself after you get them factored, any holes? Any holes in this graph where you got the same quantity up and down? No holes. Asymptote me. Give me the 3 bits of information for the asymptotes. Is there a vertical asymptote? Where at? X equals negative 1. Horizontal asymptotes, I got to check the degree. This degree is 2. This degree is 1. Right? The degree of the numerator is bigger than the degree of the denominator. That's this category right here. So that means that there are none. Everybody down with that? The degree of the numerator was 2. The degree of the denominator was 1. Greater than? None. I know that might be hard for you to read from a distance. Is there an oblique asymptote? Is the degree of the numerator 1 more than the degree of the denominator? Yes. It's time for synthetic division. Let's find ourselves a little spot to do some synthetic division. Who do you synthetically divide by? Negative 1 in this case. And I will put him in here coefficient-wise, 1, 7, 10. Right, 1, 7, 10. Let's do some synthetic division. 1 comes down. That'd be negative 1. 6 comes down. Negative 6. 4. Nobody cares about that remainder. Nobody cares about the remainder. Who is the oblique asymptote? Don't forget y equals x plus 6. This is the x, and this is the 6. Oh boy. We better have ourselves some room. We got some up top where we skipped that problem. We need a factor, and these aren't easy factor. They are frowny face factor. And of course we factored all that correctly and got x minus 2 times 2x plus 3 in the numerator, correct? And x plus 1 and 2x plus 3 in the denominator, because everybody can factor that correctly, right? So the question before you get started, will there be any holes in the graph? Yes. So we're going to start with him. Hole. At. Leave yourself room for the other vertical asymptotes, but there will be a hole. At. The question is, what value of x makes that 0? It's the same old trick as opposite of this guy over that guy that we've been doing. What value of x makes that pink thing 0, my friends? You can do it. You can do it, right? Opposite of this guy over that guy. What is it? Negative 3/2. Right, there is a hole at negative 3/2. Now we have to find the y value. So what do you do to find that? You totally cancel those guys out and you look at this guy. Right, if you got rid of the 2x plus 3 over the 2x plus 3, I want to put negative 3/2 in there. Or negative 1.5. Right? I don't care if you switch it to a decimal in math and enter it. So do that. Use negative 1.5 and substitute that in for me. I'll bet that's negative 3.5 in the numerator. Right? Isn't negative 1.5 minus 2 negative 3.5? I am putting negative 1.5 in for x. So in the numerator, did you get negative 3.5? Yes or no? Please do them separately. Don't try to treat it like it's just one problem. In the denominator, what if you put negative 1.5 in there? What would you get? Negative 0.5. Now punch that in your calculator and see what it turns out to be. If it's a whole number, awesome. If it's a decimal, math enter it. And it probably turns out to be 7. Is that right? There is a hole at negative 3/2 7. First question I have for you, did you all understand where the negative 3/2 came from? The value of x that makes that dude 0. How do you get to 7? You've got to cancel those out, and put negative 3/2, or if you want, negative 1.5 in for x. And I did that separately. I put it in the numerator, put it in the denominator, and punch that in. Are there any vertical asymptotes? So I got the hole, right? Are there any vertical asymptotes? Are there any vertical asymptotes? X equals negative 1. Whew. Sweet. Horizontal asymptotes. Go back to Mr. Ridge, right? The factored one is good for all your holes and your vertical asymptotes. Go back to the ridge. Everything you're looking for has to do with degree now, right? Who's the degree of the numerator? 2. Who's the degree of the denominator? 2. Same. So you try this. Leading coefficient over leading coefficient for me. It'll be at y equals leading coefficient over leading coefficient, which would be 2 over 2, right? Which we usually call 1. Will there be an oblique asymptote? No.
And then on to this last one here, match the following with its graph. Well, truthfully, I could answer this question without punching it in my calculator. There's nothing wrong to it, but I can tell that there's no holes in the graph because I'm not going to get the same group upstairs and downstairs because, dude, there is no group. So here's B gone, no holes in the graph. It's got a vertical asymptote at x equals 4 in that case. So this has got a vertical asymptote at x equals negative 4. That's out. It's this guy right here is what it's going to have to be. Also, you could tell this dude because it's got an oblique asymptote. It's not that case. So you could totally tell sometimes without punching in. Sometimes you do have to punch it in. So if you are going to punch it in, again, make sure you put anything that's got more than one term in it in parentheses. So zoom 6, and you'll see bada boom. That looks just like choice D. Winner, winner, chicken dinner.